Okay, so we are going to start a very new piece of software, and some people, which is called Vienna ab initio simulation package, and it is being preferred by a lot of physicists and engineers, and some of the chemists hate the software because it is less comfortable. First, there will be no GUI environment. Everything will be in the command line. So if you remember last talk yesterday by Rebecca, like preparing input files, analyzing, so everything in a command line. But it is not the all complications. This software is more like stick shift against automatic, so it will not make educated guess when it's to control many things there. What does justify use of the software that we will start today? This is intentionally created to focus on two aspects of modeling materials and natural processes: periodicity and molecular dynamics. So if you're looking at small molecules rather than polymers, if you have like isolated, if you do not have polymers or solids, maybe you do not need this software. If you need only static configurations, maybe you do not need this software for the projects. And for the future research projects in the class, I have been criticized by my colleagues who are visiting final reports, and they're telling, you are twisting arms of the students and make everyone to use us for the projects. No, you are selecting which software to use for the projects, and I don't care. Just I like this software myself. So before we go to the practical aspects of setting up input files and running the software, we need to select a model that for which the software will benefit. It is not a big problem to learn how to use the software for isolated molecules, but then it is not better than Gaussian and Gauss field. We need intentionally to look onto periodic polymers, and also it works very well for materials that includes heavy elements, like transition metals, actinides, lanthanides. So I do suggest a very simple model that for which the software looks beneficial. So if you take the oligomer of titanium dioxide that I hope you did create for one of the previous homeworks, and Dr. Han was demonstrating it. And today, if you do not have your, please use your own model, but if it has some problems or you're not confident, feel free to borrow it, like from my directory or from each other. It's not for the record which model you start from. It's more important that you follow the subsequent steps. So 1, 2, 3, 4, 5 titanium, and you do see that it has alternating pattern, in and out of plane. And if we look on the distance between two out-of-plane elements, we can measure it in JMOL. I will be doing it practically myself, but showing where we are first. And if I keep only, well, this box is not ideal. I don't need so much. If I keep only from here up to there, right? So if I repeat this unit, which has 2 titania and 4 oxygens, the next part exactly reproduces the same, right? Do you get this idea? It's repeating unit, like in polymer science, one tells like right? Repeating the same unit n times. Here we will be repeating this titanium 204 n times. So linear polymer, but it will it is like semiconducting polymer, or if you want, nanowire. So I will take this model, chop it to in a smaller element, and then convert it from like XYZ or from Gaussian format into a specific format appropriate for the VASP code that I will show how to do. But first I need to cut the thing. Another heads-on information. And it is the earlier we started, the better. There is a little technical details, a little underwater stone that kills most of the chemists who try to jump from small molecules to polymers. It's a very tiny thing, but we need to focus on it. If I will cut everything outside of this box, right? And then I will try to make a replica, a copy of this green box right after. So it ends with titanium and starts with oxygen. If I do not do special measures, it will put next oxygens right here on the same y coordinate as titanium. And it will substantially shrink the bonds between this titanium and next and the oxygens in the subsequent elements. So in addition to the elements in the box, I will need to count for this empty space, for a vacuum between periodic cells. And this amount of vacuum between periodic cells is a critical thing. If I do not do it, I will fail. The computation will give garbage. And if you agree with this subject, then I'll show how to do it technically. Just keep it in mind. Yes?
What's your meaning of putting some vacuum? So we need to bond these two, I don't know, monomer maybe, or repeating it together, or
There is no actual bonds.
In electronic structure calculations, there are no actual bonds, but there is a distance between atoms. And if I define the size of the unit cell, it should be not the distance from this oxygen to this titanium, but distance from this oxygen to this oxygen. So some amount of empty space must be included into the unit cell. Okay? And one needs to do special effort to take it into account. If one doesn't do it, it will be like a simulation cell where atoms are jammed close together, which will immediately shrink the gap to zero if it was a dielectric, or expand it to very large value if it was a metal. So it will be very wrong results. Yes?
So if I do not put the vacuum over there and then do the minimization?
No, it will not fix. It will not fix. You cannot do it. There are special commands to adjust size of the cell, but they will fix only small correction. If you start from predominantly jammed wrong size of the cell, nothing will help you.
For all the molecules?
If you do not, we should get to practical aspects very soon, but since we started, if you want to use the software that we are starting to learn for like molecules or quantum dots or isolated objects without periodicity, then one just needs to add not like one will need to add amount of vacuum that substantially exceeds bond length, like 10 angstrom on X, Y, and Z. Okay?
But if you choose different monomers or cell, the vacuum distance would be different.
The amount of vacuum for each material is different. And there is a way to calculate. Okay? I just want to give it as like one of the important things ahead of time, so that after we start typing comments, I will get excited and may forget to announce it, and it will be unnoticed. So, what is my plan? And we are starting slow, and then we will speed up and do things quicker. So, I will go onto Photon again. We will find this model, chop pieces, compute amount of vacuum, and then I will forward this coordinates to the new cluster with the scp command, and I will show the command how to transfer files, so that you do not feel you do not worry. scp. We were covering at our first meeting how to transfer files in the Linux environment. So what is the goal for today's meeting? The amount of electronic handout materials is a little too excessive. As a minimum, we should arrive to the same level as we did with Gaussian, to get the list of energies of molecular orbitals for this model, and analyze the band gap. Band gap, total energy, affinity, and ionization. If you complete this in the remaining hour and a half, it will be okay. If we have energy and additional time, it would be great to learn how to do density of states. But if there will be no time, it is okay to finish at the energies of orbitals. I know that Photon is a little slower than usual, because there is a young colleague credit student who submitted more jobs than is expected. Let's-
use your file,
Huh?
or we should copy from our previous assignment? What should we do? If we
If
want to avoid
you,
the file, it's better.
it doesn't matter. You can, but we need to start with file like this, and there are. It is not ideal in the sense, like it is really good in showing this in and out of plane things, but currently there is one point of discomfort. It is aligned on the diagonal between axes. For setting up periodic conditions, we will need to rotate it, and I'll show how to do it. But let's let me walk around and see that everyone has this image. So where did I get it? I looked for the Gaussian file, and I just copied the coordinates.
The file should be XYZ format.
Yes, yes.
But I have the .com log.
Well, you can do for let me do it. Copy .com into like test.xyz. And then in the test XYZ, I can open it, delete everything I do not need. And in order for this file to be a legitimate XYZ file, I need to add the number of atoms at the top. So it should be like 18 atoms. So when I'm editing, when I do edit of this file, I put, I'm going to the first line, putting letter I for insert, typing 18, enter, enter, and then escape, colon WQ. And after creating this file, it can be opened. It can be opened with JMOL, which is a little bit more comfortable for working with XYZ files. So I'm going to make a circle and check that. Let's go to your Okay, let's go back to where is this? Which one? Is it one? Sure. Okay.
Gerek yok. This one. This one. This one. So what should we do now? Open. Oh, you wanna put it in our directory? What's it called?
I probably need to borrow yours. It's really good. No, you use no separate. I know we are still working.
So that's a step.
A little another announcement. It's not related to what we do right now, but we will need it later. Consider to bring your laptops, especially like starting from the next lab, which will be after the break. And if you want to prepare for the next steps, look for installing a piece of software named VMD. So it doesn't help to prepare models, but in order to visualize orbitals and output of the calculations, it's really beneficial. And since we do not have super user privileges for this computer, we cannot install it here, but you can do it on your personal laptops.
Can we use a Mac system?
Oh yes, Mac is better.
Already has Linux.
Huh?
Already has Linux.
All of them. Just keep this.
Nothing? Do you permit to use a file?
I don't.
For others?
I know what it is. Yeah, that's good.
Receive or not?
Check again. Yeah.
Escape.
Oh, sorry, I don't know if there was a queue in the So you need to delete the first lines here.
Check it.
Your journey. You didn't change anything yet?
No, just keep that. I don't want to.
It's existing? Okay.
Always
so-
check it.
If you don't want to save, column, Q, inclination mark.
It's not your computer program, it's
Inclination.
mobile stuff is pretty slow.
it's not Mobex term. It is Levi Westrom who's overusing Photogen. If you want to acknowledge someone for being slow, there is a name.
It's not me, is it?
No, your name is not Levi Westrom.
I was like, is it still calculating those
No.
figures?
.com or .xyz? No, it's XYZ. You have? So a new point that you could make, you should open it.
What's your name to the test?
So,
Using both tape.
No.
CP is only copy, it's not converting.
what is the name?
It's you. No, this is you.
XYZ. This is the last one.
I know it is. It's first. Let me do something.
Definitely, it's really that you need that box. Why did you delete that? What is the problem with that? Let's try it. Let's call it again. Okay.
It's in the Microsoft Word, but in the original.
How did you do it? You did anything? But why it doesn't work for me? I have it. It's here. So we had to copy XYZ? Are you kidding me?
This is because of the optimization. Because this
It's cool, but we need to accelerate many things quickly. Matrix allows to use curved averages really good for the purpose of the business. Yes, yes, yes.
So how did you put that Oh, no, you didn't delete the file.
Yeah, fold.
For the use your geometry in the either open and close, you can say under the or use Babel and convert from close to close. But right now, the story is about other things. Yeah, let's help each other. Were you able to open it in Gmail? Gmail, yes.
Yeah.
Good.
Do we need to delete the title in the next one?
Let me Oh, you already have it. So you have it. Why you told it something?
So I changed to another one. Okay. And it will change the head.
But the title doesn't matter.
It was the comment display. Access or
Both.
one remote.
So who else needs? So I'm measuring the periodicity, and just in case I can, it should be the same, or approximately the same between any other pairs of atoms.
How did you measure that?
Just click initial and measure distance. Measure distance. And the so it is 4.365. I want to record this size, and now I can delete the atoms that I do not need. So a little comment: half of the class use this file, half of the class are using the one borrowed from Mahek. The file from Mahek is better. A little, there will be a little less operations. I will show how to process this one, but those who are following her file will live an easy life. One operation less. So the difficulty is related that we will need to rotate this file by 45 degrees. And the one that originates from Mahek is already aligned along one of the axes. So the model should be aligned along one of the axes in order to impose periodicity. It is not like scientifically mandated, but it is so much easier to set up periodic boundary conditions if the axis of the periodicity coincides with one of the Cartesian axes. So I am going to click red cross, not because I need a medical help, but because I need to erase some atoms. So I'm going to erase this,
We should do
this,
it also?
this, yes, this,
Would you make the same?
yes. So I left only a very small fraction. And now I want to save it under the new name. Save as, and I be creative. I call it like sort.xyz, but it is not mandatory.
Save the file?
Huh?
Save it?
Save it under new name.
So with which format? XYZ again?
Yes, XYZ. I will keep this JMOL window for a little time, but I do not need it actually anymore. So I'm looking on here, US minus OT, and I do have this sort XYZ. I look inside, and I do see that in this file there is 2 titanium and 4 oxygens. I'm showing a command, but it is not needed at this time, just in case. Sort XYZ into xyz. So sorting. So there is a little detail, and do not worry, I will repeat it again and again. In the Gaussian Gauss-U software, we were given names of each element in the model, and it was allowed to list oxygen, then hydrogen, then oxygen, then carbon without any order. Last software was written by people who like when everything is organized, and they mandate that all atoms are arranged alphabetically. So all carbons first, all oxygens second, and this sort command helps to do it. This operation I'm fixing that there is a number of atoms, then empty space, and then the list of elements. Now, we are almost ready to go. This will be the only file we need to move into the new cluster where we will be doing things. But there is one operation more that we can do here. So we need to rotate it by 45 degrees around z-axis. So those who do have this image rotated will follow steps that I'm doing. Those we will set up the rotation angle 45 degrees. Those who are following Mahek will just set up rotation angle equals 0. And do not worry, I will repeat the things. We going slowly.
Can you please a little increase the font size?
I will. It is already increased when we will go to the cluster. It's just last minute on the photo. So rotate XYZ. So one needs to put 3 numbers, and those for whom the angle was not aligned, same as for me, should type 0, enter, 0, enter, 45. Those who will follow Mahek should enter 0, enter, 0, enter, 0, enter.
Rotate underline. What was the comment afterwards? Underline XYZ.
Uh-huh.
But it's making error.
I will make a circle and make sure that everyone is on the same page and just complete the logical step. And the last step, right now I'm on the different cluster in the directory that I have created for my personality and for this lab. And then I'm copying the files that start with the word postcard from the photon. Of course, I'm not typing this long path, I'm just copy pasting. So photon, column, and then path where these files are located. Space, period. And now, huh?
I'm doing this on the NAS.
Yes, I'm on the NERSC. I'm telling, I want to take files from photon. Okay? So I'm going to make a circle and check that everyone is on the same page. Feel free to approach the front station and swap windows or scroll up if something is not visible.
So
You do not need me for this.
So generate this one into this? What happened?
Okay.
So this my classmate. That doesn't work.
6. We need either 2 and 4 or 4 and
So I need to use this command, right? Rotate this. So how it can understand the name, the point name?
I think.
Rotate one. Where did you?
You just keep it visible.
No, we need to start it. Change the founding.
Are you sure?
Yes.
Copy,
Did you
type it.
understand when to rotate and when not to rotate?
Yes. So until now, we are not alone X or Y axis. So we use this command.
Is it X? No, I think it's around X, right?
Yes, now it's X. No, no. Here is an axis. It's have a 45 degree with X and Y.
So it needs to do with X and Y or
A little X.
axis? Then why we do 0, 0 in C4?
It means the resultant Y is X.
Please do not use spaces.
This is the Z axis.
Yeah, I
And long, right, long is
So why we need to change the name to postcard?
This command only specify this files.
Doesn't make any sense.
And then copy this one to CP, copy this file.
Now we will same page with everyone else. I need to help understand.
Here,
Okay.
What is it?
Just one videos.
Also?
Are you from my? Yes. 0.0.
No?
There's no more copy this. Sorry.
What does it problem? But I didn't get why we rotated 45 degrees.
This axle along X almost.
Why?
Because
It's working.
but if you do have this kind of materials, you can figure out
Because you have come with just replicate the coordinates. to use one of the photon server, right? Yes, you're correct. Color, yes, please. Like a slash, right? Yeah. Oh, we should bring it to the.
Let's copy it to the person.
It should be used.
There's everything in the key or no? We should go to the other one. Look at this. Where is the key? We should go to the other server. Yeah. I just want to copy it.
Yes. Copy the stuff for everything as well.
We need to copy the postcard, right? Postcard. Wait. So, thank you. So in this directory or no? Look at this.
It's in the
Global. Global home.
just CPR M125.
Yeah, like
Now we have to copy here, right? Copy down, carry this file here. What's the file directory?
oh yeah,
Kill it, total. And this another one.
How can I check whether my position is fulfilled?
Right?
Oh, yep. Are you following me? But no, you did it after. I think it wasn't good. No, you just first command, and source, and then destination. Okay. No, it shows where you are. Then after this carrot, this thing. Call you? No?
Get some information.
Okay, but you restart doing things in the terminal and install the dkilin. Oh, okay.
So this one was not.
Go to there.
I understand, but let's look.
Kill it to nurse. What was the name? Really?
Nothing will work. Why do this work? We need to erase it. So in periodic cell, we need starting from here and there. Just do it yourself.
When we put this install,
Yeah.
it means that copy all
Yeah.
the
And then
all time.
Yeah.
Yes.
No, actually,
That's
it's
the
not.
one. Yep. And now save under save. Oops. Yeah, that's good. Okay, good. So if you're following this file, you need to take 0.05. You need to go to this.
Thank you.
Gentlemen,
Hi.
how things are going?
Yeah, it works.
It works? Over to you.
Yeah, but why we cannot open this file into the Gmail?
What do you mean?
Just show whether the molecule about the X or Y.
I got your question. So there is a way to open and check how you modified it, and I will show it with time. Just it's not our primary focus because there is only half an hour left, and I want to show you most important things. But I will either bring it myself or you can remind me. So now I am going to open. You see this file, you have it, right? It is little notes that I was handwriting for my first graduate student 10 years ago, but I think nothing can be done. I cannot do it better, so it's just copies. So a little break. Before we go further to practical aspects, I will be mumbling something more general. How many input files do you have in Gaussian? Input. Huh? One. .com, right? Do you think it is the same for all pieces of software? Okay, so it is one of the reasons why some people hate WASP. So it does have 4 input files, and each of them has specific reason. I do not know what car means, but the creators of the software like this ending. They call everything with ending car. So pos car is a position. So it's positions of ions, and we do have a little additional step in converting XYZ into specific format of the input of the coordinates of atoms for the WASP format. I will focus on it in a very short time, and it is main goal of today's meeting. The in card is a list of options that tells which sort of a job will be done. So it corresponds to drop-down menus in Gauss view of selecting method and selecting job, like whatever frequencies, optimization.
So the comments are included in this file, right?
Yes. And spin multiplicity, like Rebecca was teaching us yesterday. So all things like this information is included in the in-car. Of course, format will be different, but the content, the essence is the same. Then K-points is a specific thing that is completely missing in Gaussian, and we will return to it again. In isolated molecules, electrons always sit on the atoms. It will be very strange to see the spontaneous ionization and electron traveling away from the molecule, right? We do not see it unless we do photo effect or strong electric field. In solids, which are periodic, in polymers, there is no dedicated marriage certificate between specific ion and specific electron. An electron is free. It can move to another ion, to another ion, to another ion, infinitely. And it is not just spontaneously decides to move. It can be moving with constant velocity all the time, even for the ground state. And the file K-points corresponds to this feature. It tells how quickly electrons may move in respect to ions. For the first couple of meetings, we will not modify this file, we will just use it from the template. Now, remember the lecture, or mini lecture of Rebecca when she told that in Gaussian, after you tell everything you want to tell, you can describe mixed basis set and do some additional specifics. So in VASP, you always need to do it. So PODCAR stands for potential. So the information about which elements are entering into the model is explicitly stored in the numerical way into this file. Of course, in the PODCAR, we can name and call them by the label, like C for carbon, AU for gold, but this is only a label. The information how to represent each ion, what will be the potential attracting electrons to the core strongly or weakly, how many electrons are needed for specific element, is explicitly stored into this card. So it's like stick shift. And I'll show templates how to fill these files.
This
But
is already in VASP.
it is for the VASP, yes. So the most critical thing is PODCAR. If you do not know how to create positions, then there is no reason to focus on others. After you did this little rotation, there is one more step for that some of you have already tried to practice. So there is a little script, and there is no standard way to create VASP files. This is a little handwritten code, and you may find ways to convert input files into VASP in some specific software for crystallography, but this is a shortcut. So we are going to type this script, then the name of the file that was created upon rotation, and then the name of the file that we are going to create, PODCAR, and after this there will be 3 numerical parameters. These 3 numerical parameters is what we were talking at the very beginning, is amount of vacuum contributed in each direction for this model. So if you're looking to describe only isolated molecules or quantum dots, you just liberally add like 7 or 10 angstrom, right? But if you do periodicity in like x direction and nothing periodic in others, then you add liberal amount of vacuum in aperiodic dimensions, in those which are not periodic, and give specific amount of vacuum corresponding approximately to the bond length in the direction where periodicity goes, right? And we will discuss how to compute the amount of this vacuum. So if you have farmost atoms to the left and to the right, and the next periodic image, next group of atoms will be here, we need to know the amount of vacuum we need to add, right? So how to compute this amount in our specific example? I need a minute to prepare demonstration so that you do not look on me. I will need a couple of minutes to prepare demonstration and then show. So I did some operations that I will show later. I'm just skipping them, but they are answers to your question about how to see what happened after the rotation. So this is the model after it has been rotated. Now we do have periodicity along x-axis, and now we need to count distance between these two planes. So if I'm good in geometry, I can make a triangle, solve for its parts, and find this distance. Or if it is aligned along the axis, when I do click on the atoms, I clicked on this titanium and this oxygen in the model, it shows 3 Cartesian projections of each atom. So those are x, y, and z of this oxygen. Those are x, y, and z of this titanium. The distance between these two planes is equal to the difference between x projections of these two atoms, right? So I need to take these two numbers and subtract them. So the result of this subtraction will be amount of vacuum I need in preparing the input file. Make sense? So I'm going to type you can borrow the numbers that I will generate for now, and then you will repeat it in the homeworks or whatever. So if there is a command BC, which is like board calculator, and I'm typing this 3.635. Enough. One doesn't need many. So this number minus this number, which will be 2.5453. So this 1.09 is the amount of vacuum needed to make this simulation cell healthy. Right? So, and now I'm typing the command seven, and then wait, this number, and then the liberal amount of vacuum. So this command is mostly non-trivial and creates a little confusion. The rest will be straightforward. So you run ting to wasp space. This file was created as the result of rotation, then space. This is the name of the target file, and here I'm adding the amount of vacuum along axis, which needs to be precise, and then amount of vacuum along x and y, along z, y and z, which is if you take it a little bigger, it will not change the results. Ideally, if you have unlimited numerical power on your cluster, you can put like 10 or 15 angstrom. But in VASP, vacuum costs something. The larger the amount of vacuum, the more longer will be calculation. And if your amount of vacuum is bigger than 7, maybe bigger than 8, you just repeat the same calculation with different amount of vacuum, results will converge. They will stop depending. Enough. I'll tell details
So
more.
it means that if you put the reasonable amount of vacuum, it will help the system to be optimized with less computational effort, something like that, or
You need to use. Let me hit enter. let me
Because
draw.
at the end,
Let me draw something. Let me draw something here. So the model consists of repeating units like this, right? So although we explicitly give coordinates only on one unit cell, the software assumes that the whole universe is populated by these titaniums and oxygens. But in this x direction, they will be close to each other. And in other directions, in the other directions, there will be this 7 angstrom of vacuum, and then there will be the same pattern, right? So the whole universe is populated by titanium dioxide nanowires, but in unit cells. In x direction, they're close to each other, and in y and z, they're far from each other, right? Good.
So this vacuum, sorry if I get
Go ahead. Go ahead.
You want to define that maybe or help them to be in a reactive field. This means the vacuum. When this vacuum space becomes larger, it's maybe hard for them
Replicas
to react each other.
stopped in interact to each other.
Right.
If they close, they can electrostatically attract or repel, and orbitals can hybridize.
Exactly. So,
And we do not want this.
so if they be in the right distance,
Mhm.
if not, maybe because of the
The
competition
bigger,
of efforts,
the
yeah.
bigger, the better for correctness of results, but the smaller, the better for quick calculations.
Right. Okay.
So we and one yes,
So in that case, are we giving the cutoff for the interactions?
we give what?
Cutoff, like this.
Cut-off distance, you mean?
So by specifying these values, are we giving a cutoff of interactions between these two
Yes,
replicas?
yes, perfect formulation, yes. Just be careful with the word cut off, because in the language of the software, cut off means something different. But you're correct. They use cut off for the basis set. They have a little different terminology. So please practice this command. Just type it. And then I will make sure that you do not have error, and then I'll come back and give the rest of commands.
Technically, may I have a quick question?
Oh, please do, please do.
In the molecular dynamic, when people want to, for instance, model a reactive chains, okay?
Mhm.
They put some pressure on the system and study in the different time.
There is a way to apply pressure here.
So
There
here-
is a way to control pressure,
And we
density.
will study in the different time steps. It's a dynamic.
It's available. Numerical cost of all these tricks is noticeably higher than in force field dynamics,
sure, yeah.
but it is all available.
Thank you. So, did you take a picture or something? Okay. Thank you.
So you just have this command. Always
Take two masks. What was the meaning of 77? Oh, yeah, in the y direction. Seven. So one of them is x, the other two seven is y and z. Right?
The first one is x, the vacuum is x.
Oh, yeah, that's good. Okay.
So what happened now?
I see.
Did
Yeah.
work for you?
Yeah, but after the correction, the vector changed to 11, from 7 to 11.
It was not 0. It's like 4 plus 7 will be 11.
4 plus 11.
Okay, now few steps more.
5, 11, right?
Huh?
I think it's okay.
Yeah. So copy. I'm going to copy templates from binary in car.
We should do it also?
Yes. GM and into here, and we will call it just in car. So I did copy the in car from the template. You see this binary in car GM for geometry optimization, and I can do VI in car. I will bring back this command again and see what is here. So later we will discuss in a lot of details what to put here, but for quick calculation I make sure that the NSW is equal to 0, which means single point SCF, like no geometry optimization. If you want to do geometry optimization, you change this number to whatever 100.
Oh, it's a comment of the, what was the name?
It's one of the 4 input
It's
files.
in car?
Yes.
Okay.
So
Yeah.
here I just copied it from the template, named it as an in-car in this directory,
Yeah, okay.
and make sure that the files do have the assigned names, because the actual software looks for a file with certain name. If you call it in-car number 1, software will not recognize it.
Good.
Okay?
Can you keep the comment, please?
Yeah, absolutely. Copy.
Is there any space after in-car? No. No. In-car GM?
Then I did copy this from the binary k points, also space here, copied into this directory, and now I'm missing one file more, the podcar. This is not very difficult, but it needs a little attention.
We just copied the file.
You did copy in-car and k points.
K points.
For the podcar, we will be creatively creating it. So
This file already in the.
yes, templates. We need total 4 files. 1 you have created, postcar. 2 in-car and k points you copied from the as a template. And then the last one, podcar, we need to fabricate it. So I'm typing. I assume that these 2 files were easy to copy. You do not need me to check. Module show wasp. So this command inspects the directories for the software on this cluster.
Oh, it's there?
And this, it shows pseudo potentials here. I'm copying it and here, postcard. So in the postcard, if you look inside, oh, I have forgotten to surprise you by a little more thing. If you look inside the postcard, how to read it? it doesn't look like your Gaussian input or PDB or anything you saw before, right? So we need a little bit interpretation of what this file means. So first, it shows elements which are used to compose this file. Oxygen and titanium, right? No complaints. Now, how many oxygens? 4. How many titanium? 2. Now, if we look for the whole file, total number of atoms should be 6. 1, 2, 3, 4, 5, 6. So first 4 of them will be oxygens, last 2 will be titanium. But note that there is no labels of which element is here. It's so confusing for traditional chemists. Like, where are my elements? So when we need some dictionary, it's oxygen, and we need to count 4 oxygens. Now, if you looked into the original postcard file, the x, y, and z coordinates in angstrom were changing from 0 to like 5, right? Do you see any number between 0 and 5 in here? No, they all are between 0 and 1. How to convert them into the regular angstrom units?
Times the vector.
Exactly, exactly. So these 3 numbers on the diagonal of this little matrix is the size of the periodic cell. It means along x it is 5.09, along y it is 11, along z it is 11. And then you need to take this number times this number, and then you will get x coordinate, x projection of the coordinate of the first oxygen atom. Okay? So this trick is called fractional coordinates. And it gives why we need so many complications.
Can you say that how we got the direct? Also, we can write it.
Wait. I'll go to your questions. I'll illustrate it. Fred Oscar dot XYZ. Well, it was before we rotated it. There is a matrix 3 by 3. Typically, only diagonal elements are non-zero, and the values of diagonal elements is the size of this periodic box in angstroms. Then this 3 number for each element tells how many percent of the unit cell this atom is offset from the origin. It changes from 0 to 1. And if you need absolute value of the coordinate of like x projection of first oxygen, you take this number and multiply it by this number. So 5 times 0.8 will be about 4. So the coordinate of the x coordinate will be about 4 angstrom. Okay? And TTT means that it is allowed to translate. Later on, you will see that there is an option to freeze, to forbid it to move, and then it will be FFF.
Also, I can write this in a Cartesian form.
You can, but let's start from this one more standard. So what's the reason for this form of fractional coordinates? One wants an uniform way to describe any model. No matter how big or small it, all coordinates will change between 0 and 1. So for computational procedure, one will maintain the same precision, same protocols. Okay?
So the initial the cell size is 4 by 4 by 4.
For this model, it is 5 by 11 by 11. Because we added vacuum in x and y, in y and z directions.
So if there's no vacuum,
then if I would do this command, if I would create postcard file with arguments 0, 0, 0, it will be 4 by 4 by 4.
yes.
But I do not want it to do it because it will bring some non-reasonable results. Now, module show wasp, pseudo potential directory, pseudo potentials. So just type this module show wasp.
And Dr. Dimitri, we missed the last copy comment before doing this procedure. You
Just
copy the incar.
after the key points. When we enter.
You copy the incar.
Okay, yes, I've got you.
Yeah.
This one?
After that.
Before that.
Before that. We did this. Yeah. What is the next one?
With the think, with the key
No, before one.
Yeah, but after this.
No, no,
Yeah,
only
yeah,
two.
sorry, yeah.
Only two, no more.
No more.
One after this, the key point, right?
Yes.
Yeah. Could you
No, we
please?
still don't have the pod card.
We are missing the pod card.
Can you put us the?
And I hope it will be recorded, so if you need step-by-step things. Okay? So, cat, it's not like animal with whiskers, but it is concatenate, then paste these pseudo potentials.
So for the potential, we have to write what command we apply.
No, you copy paste it.
Yeah, but we didn't write the module that you give for this.
Let me write down what you type. Module show wasp. Look here, module show wasp. Okay? And then I'm copying. So the first element is oxygen. If I keep pushing the tab, then it will show that in this directory there is a list of all elements, and for each element there is a template of the pseudo potentials. So when I do practical effort, I'm typing this cat directory and then telling oxygen slash pod car for oxygen, bigger, pod car, enter. And then doing the same for the next element in this model for titanium. So I understand it looks a lot, but the pathway you just copy, and the only thing that you need is the last part of this long line. So for titanium, pod car, bigger into pod car.
Can you let us?
I think we need to design some decent homework for the break based on this commands.
Out the domain.
Let me make a quick tour.
Oh, this is the first one.
It's going to take a look. Did you copy this? I'm just going to scroll up.
Then you can just copy this directory.
See the potential.
I can do yeah,
Let me just
I don't know.
Yes.
But you didn't
PCL.
Slash. And this like PS.
PS.
Yes.
Get me last. I'm trying to figure it out.
Yes, yes, please, please.
It should be the capital O.
So what is the next one?
Just change the type. Something else, right?
Finish? Did you open it? Where is this? What's the point for me? Oh, we should be on with it. So worry, I get results. Global, common, Eastern, Israel,
You don't need to wait it here.
Siena, Haswell, Wasp, Pseudo, potentials, PV, right? Code all PV, titanium, code card. Global city. Pakistan.
I'll explain. You're fine?
Again.
Yes. It is wrong.
Oh, really? Postcard to postcard? Or no, postcard?
Try to put the postcard from my director.
Okay.
All good?
Yeah. Postcard to circular.
Postcard, points.
That makes all 45 value, right? 3R, lowercase r. Finish?
Okay. Yes. Okay.
We finished for this session, Dr. Dimitri?
No, there is one more important step.
Okay.
Just report me that everyone is complete with the steps, and then I'll tell what to do next.
There are 5 people cases.
So, how much in those records? I think there is no one in no Sakuta to check the patients.
Yeah, just do the same thing. So you're done with having 4 input files, right?
Yeah.
Now the actual submitting the job. Please copy from my directory the files. If you look, there will be .sh. So copy this query debug sh and yes, and since we are doing a very small job, one can use only one node and one core. But later, as you need for resources for calculations, don't hesitate to be liberal. I have like 12 million CPU hours that I need to utilize, so just help me to spend resources. And then you type as batch, okay? And it tells submitted job. So when you type SQS grep number of job, it will answer that job is already running. So letter R means it is running. It is already running for 8 seconds. If I do it once again, it's already running for 22 seconds. And then you see we stopped by having these 4 input files and the script. As soon as please do these things, please submit the job. As soon as job starts running, like Gaussian creates 2 output files, .log and .check file, right? Wasp creates like a dozen files. It's life. And
So can you let us know again how to
submit the job?
and how to copy it? Where was the submit job?
But please raise hands who needs this, who doesn't have this bin script yet. 1, 2. You just copy from right here. No.
Just complete this copy. CP. Yeah, that's fine. Then just
Copy with some
Yeah.
to our
Yeah. From the where?
yes.
is running.
We just didn't get where to copy the
Summit
files.
Okay, if you return to SSH. Oh, it's changed. And then you just
So, how many processes do you have for
64.
And don't let me how many nodes do you have because you will occupy all of them.
About 10,000.
Right. You did that?
So SQS grep. So it is already running. Okay. And then
I will wait.
okay, so after the job starts, it creates several files, and if you look OSICAR, it shows iteration steps for electronic structure. If you get if the OSICAR tells this 1F equals something, it means job has been completed. The analog of .log file is outcar, like output.
There is not a specific.
So if I do more of the outcar, it will show as much garbage information as much garbage is in Gaussian.log file. But if I scroll far enough, closer to the end, let me show a spot that you will recognize. So one needs a spot in the outcar file that follows the word Fermi energy. So there is a list of orbitals, list of their energies, and list of the number of electrons occupying certain orbital. And for this model, the Homo-Lumo gap is substantially smaller compared to Hartree-Fock that we were doing in Gaussian. So it's about 2 electron volts. We didn't optimize. Maybe there is accumulation of other errors, but please try to look into the outcar file and find this record. I will compose a homework for doing calculations for a few other models and finding these values there. Energy of Homo, energy of Lumo.
So here is for submitting the job, right? Yes, that's correct. So job is submitted.
Oh, you
Okay. How should you do it?
if it shows nothing, this is your job.
another comment? SPS.
See this.
What is this?
Check the
Oh, yeah. SQS. This great. What's this number? No, processor or no?
So I don't know.
Why it doesn't work? Yeah, good. Good. What's that then? What's the name?
This should be alpha OS R.
Nothing. Let me take a photo also. Yeah, it's not accurate. Yeah.
Did you? Were you able to find this spot? Huh? Out car. Yeah. More out car. Mm-hmm. Not Aussie car, but out car.
So the job still running.
No. As soon as it write this one F equals, this is total energy. Or free energy because it gets thermodynamic.
This is
Yes.
warning.
Only for you. They put some jokes.
Warning is there is some error, practically.
No, it's only warning. Okay. So it's about 90% close to. So, yeah. So about 2 minutes. And so it goes iteration cycles, same as in Hartefok, right? And then after converges it gives total energy and orbitals.
Okay, thank you.
So scrolling through outcar files sometimes is a little exhausting. So there is a smart way to do it, or like a little trick. So you have noticed that right before there are some keywords like band, energies, occupations, Fermi. So if we type grep Fermi outcar, it reproduces the line with Fermi. But we can do grep minus after 30, and it then shows 30 lines after the keyword Fermi. And then we immediately get into the right spot.
Can you show the code?
Yes. And I think we got enough. It concludes the session. Right? You already invested too much time. So there will be no new information. I'll stay here and answer questions if any, but nothing new. And XB. So it's just a way to, instead of scrolling, because this is very small thing. In the future, we will have 1,000 robots for everything that we already. Yeah, many thanks for your questions. Thank you for your time. Oh, I enjoyed it very much. So I think, next week we have vacation, or how to call it, break.
Be careful about the coronavirus. So
Right. if you will have any questions about the class, I think the connection will stay active. If there will be, if any of you needs help, we can arrange the same. Well, no one of us need to come on campus, but this is going through active connection, and we can have a like online consultation.
Sure. Have a nice.
You do?